Question 31, for two similar triangles, ABC and DEF, such that A, B, and C correspond to DE and F, respectively, how many feet long is DE when AB is 10, BC is 12, AC is 15, and DF is 12? So the key here is that they are similar triangles. And if you recall, similar triangles have the same angles, but they're not necessarily the same side lengths. So just as an example, I can have a triangle like this, and then I can have another triangle like this. So that's just a scaled version of it. So if this is one angle, this is some other angle, and this is the third angle, this scaled version will have the same angles here, but clearly the sides have grown. So if we were just to pretend that this is a right angle, just to make the numbers nice, pretend this is a right angle, pretend this is a right angle, and let's just say I gave you 3, 4, and 5. This could be something like 6, 8, and 10. So if you're looking at this triangle, you can see that they multiplied all the sides by 2 to get these, or vice versa. To go from this triangle to this triangle, they divided all the sides here by 2 to get these. So that's a quick review of similar triangles. I'm not going to draw a right triangle because it doesn't say that in the problem that they are right triangles. So instead, I'm just going to go ahead and draw two triangles that kind of look like right triangles, but we don't know if they are or not. So I'm not drawing it in because it doesn't say that they are. All we know is that they're similar. So let's label them. So we'll label this A, B, and C, and this is going to be D, E, and F. And you also want to make sure you follow the order. So if they're saying that A, B, C is similar to D, E, F, you have to write those in the same exact order. And they're saying AB is 10, BC is 12, and AC is 15, and they say DF is 12, but they're asking us about DE. They're saying, what is the length of DE? And they are mentioning feet here for units, but in this problem, you don't have to worry too much about that. Okay? So what we're going to do is set up a proportion, right? If I can multiply all these sides by some number to get these, then I can set up a proportion to compare the two. So what two sides am I going to use? Well, if I'm given this side here, DF, and I need to find DE, I should compare those sides to the similar sides in the other triangle. So what is similar to DF? AC is. What is similar to DE? AB is. And I'm going to set the proportion up that way. So we could say 12 over, and then for question mark, we'll just call that X. That is equal to 15 over 10. Now I could have also flipped this. I could have put the X here and the 12 here and the 10 here and the 15 here. All that really matters is that you're comparing like and like. So if I'm comparing, let's say, my long side here to the shortest side in this one triangle, I should do the same thing in the other triangle. I should compare the long side of this triangle to the shortest side of this triangle, okay? And at this stage, you should recognize that you're just cross-multiplying to solve. So we're going to have 120 is equal to 15x, and then to isolate or solve for x, we'll divide both sides by 15. So 8 is equal to x, so our answer for this one is going to be A.